Assalamu alaikum, guys. Good afternoon. Could you hear me, guys? Hello,
Yes,
guys.
Miss, we can hear you.
Okay. So, I can see students are still joining. Okay, fine. Do you remember yesterday we thought or we have decided we're going to solve some uh, general physics questions from previous years, like I decided we can start from 2011. Do you remember, girls? Yesterday we thought it like that.
Miss,
Yeah.
one more thing
Yes.
was when I was checking the papers, they gave paper 1 and paper 2, like for physics.
Okay. Paper one and
So,
paper two, I didn't understand. Is it about A level you're talking about?
yes, Miss, yes.
Okay, fine. They call it paper one, paper two because it's unit one and unit two. So you will find it out. No problem. Unit one,
So
two,
these
and
are the
three.
units.
Yes, dear. Say again.
These are the units then?
Yes, yes. There will be three units on the page. Means in grade 11, you'll be having unit one, two, and three. Unit one, you'll be writing in January, two and three in December. Sorry, in that is June. Okay, we have two sessions, the regular sessions. And October, November is a repeat session, I told you, right? Okay, fine. So as I told you that whenever you're free at home and you're not doing anything, go to the net and check. You just write down the Excel syllabus, subjects and all, you'll get out all of this one. You'll get to
The
know.
thing is that they don't give it for like free. It's like mostly you have to sign in or you have to pay.
Okay, is it like that? I
It's
don't
not
know.
like Dynamics where you can download it straight.
Is it? Okay, I didn't know that. Okay, I have to check and tell you. Otherwise, I have the syllabus for unit one. That one I can share with you. I'll take a photograph and send it to you, especially the unit
So, Miss,
one, the
for
one.
each unit, there is a different syllabus?
Yeah, definitely. Separate topics, separate syllabus. But unit one and two together, the practical questions will become unit three. Okay.
And then, Miss, are we going to have like practical exams, like paper
No, no,
5
no,
exams?
no. There will
Well,
be no practical exams.
our
It will
school,
be alternative to the practical, like IGCC we do paper six, same way.
Paper 6.
Exactly.
Okay.
well, Ajira, our school does not take Cambridge because Cambridge has
Yes, they
practicals.
have the practicals.
Yeah,
We
yeah.
don't have the practical
No, I was
support.
reading through the syllabus yesterday, so they were saying about many practicals and other things.
Mm-hmm.
And I remember the senior app was going to the lab, so I know
No,
they.
you'll just go to the lab and have a look at those. Means in chemistry, you might be doing some of the practicals, but will not be having any practical exam. It will be alternative to the practical, like we had in our IGCC, like that it will be. Okay, fine. Yes. Now, tell me, guys, are you having 31 May June 2011 with you now? Because I want
Miss
to
what?
31 May June 2011. Because I decided
Yes.
11 onwards, we want to check all the questions. We'll have a discussion.
Miss, give me 2 minutes. I'll just find my past paper. Don't worry.
Okay, do it, no problem. I'm waiting. We can wait for a few minutes. By the time, I will just talk to others. So,
Assalamualaikum, Miss.
walaikum salam. All of you, please take out that paper. 31 May June 11, question number 1 I want to do. And you know, the AP paper, we have 3 for general physics question. And of course, as you already came to know that unit 1 of A level is also nothing but the general physics. Mostly it will be general physics topics. So let us just go through general physics one more time. It will be helpful for you. I told you all the knowledges that you are having for IGCC, it will help you in A level, definitely. But these same topics, force you'll be learning there, types of force, and there will be some more added informations for you. For every topic, more equations. The one we didn't address here, you will be doing it in A level. So nothing different. Okay. So I want you to have 31 May to 11, question number 1. I hope you have with you in front of you now. Otherwise, you won't be able to do it. First, just take your past paper and keep it in front of you so that we can have the discussion.
Miss, unfortunately, I took out the wrong paper.
Okay, find it
I
out. No
took
problem.
out paper.
It's paper 3 means paper 4, 31 May to 11. Question number 1, I want to check with you. Okay, like the rest of the girls, like Orpa, Zerine, I hope all of you are having with you that one so that we can have a discussion. Do you have with you that paper? Like
Yes, Miss. I just brought the past paper. Yes.
Okay, very good. So let's just have a look at these equations because the questions that we have here. First, if you just look, the first question is like, in a laboratory, an experiment is carried out. Listen, guys, since we are doing it from grade 8 onwards, so some of the questions might be already done in your book. But then also I want you to go through it one more time. Just a revision. As I told you yesterday that this time you were supposed to be writing the IGCSE and you are not supposed to have any regular class. But the situation is different, so let us make use of this time. We can just go through all this topic one more time. That will be helpful for us. Okay. Now, in a laboratory, an experiment is carried out to measure the acceleration of a trolley. Okay, this type of questions will be getting a lot. A trolley on a horizontal table when pulled by a horizontal force. Okay. The measurements are repeated for a series of different forces with the results shown on the table. Okay, they have given us a table and they have given us a grid. You are supposed to draw a graph over here. Okay. Now, I want to ask someone like, Zareen, is it done in your past paper? In this particular
Yes, Miss. I've done it. I've drawn a graph and yes.
Okay, okay, fine. So could you tell me what was the pattern of the graph that you found there?
It was a straight line with a constant gradient. It was.
Okay, but is it like it is going? Did it start from origin?
I've connected it to the origin, but it starts from 0.5 and 4. So yes, it does extend to 0.
Okay, but when you connected it, did it come to the origin? Did it meet origin?
More or less. I didn't do it with the scale. I guess I didn't finish the question. I'm not sure about this one.
Yes, actually, okay. Who else has this question done already from this group, guys?
Miss, it does not meet the origin.
It came from origin?
No, it did not.
Yes, that is the one I was telling you. Because if you join 1, 2, 3, 4 points accurately, then it will never come to origin. It will actually have a y cut. Means in the y-axis it is going to cut. Okay, then from there we get the question B from there. In B they say the graph shows that below a certain force there is no acceleration. Find the value of that force. Okay, if you just look at it, as I told you, if you draw the straight line, it will have a y cut. So whenever the line is going to cut the y-axis, that value of the force will not have any acceleration because that time it is zero acceleration. So if you read out carefully, like I did, I got it, let me see, okay, I got it around 1.2 Newton. Okay, Noreen, could you tell me what was the value that you found over there? I got it 1.2 Newton.
Newton as well. I got exactly.
Exactly. Yes, actually, if you draw it very correctly, then you will see that after 3 square, it is going to meet the y-axis. Hence, the 3 Newton, it will become, no, it is 3 square actually, not Newton. And each square is kind of 2 by 5. So 2 by 5 multiplied by 3, we are getting 1.2 Newton. Okay, fine, that is correct. Now, check the next part of the question. They say, force smaller than that in B1 is applied to the stationary trolley. Okay, such is what happens to the trolley if anything. Because 1.2 Newton is the one, if you apply, it will not have any acceleration. So what could be our answer for this part? We are applying less than that. Yes, it will stay stationary, definitely. Because we are applying less than that. So it will not even start moving. It will be stationary. Fine, good answer. Now take the next one. They say find the gradient of the graph is about, okay, we need to do the calculation. So as we know that if you want to find the gradient, you choose 2 good points on the line and draw the triangle and use the triangle. And if you do it, and of course, write down the equation y2 minus y1 divided by x2 minus x1. And if you do it, I got it 5.71. So that matches with the answer that they have given to us. How much you got, girls?
5.71.
Okay, fine. So that's matching to us because if you look at the line that we had, second point, the second plotted point, and the fourth point, if you take, they are well on the this line. So if you take them, then you'll be getting the data. Yeah. State the equation that links resultant force F, M, N. Everybody knows that, right? F equals to M. Right. So using this one, you will be finding out the mass of the throttle. So we know we are going to rewrite the equation. M equals to F by A. Then F is, they gave us F is, okay. I think we don't need to do anything because already we got the gradient. We'll just place the gradient value on the here because the gradient itself is nothing but the mass. So M equals to F by A equals to 5.7 kg. Here we have to write down kg because the unit of mass will be kg. That's the point. Okay. Now, if you check E of the question, on the figure 1.3, they have given us a graph line, means they gave us the x-axis and the y-axis. Okay, actually with the constant acceleration. Okay. So, what type of line you are going to draw there? If it is a
It will be a positive gradient, that constant line,
means
increasing speed constantly.
yes, it means that you're going to draw a straight line from the origin. When two quantities are going to be having a constant acceleration, means the constant gradient, then the line has to start from the origin and it will go straight. Anyway, it will go up. No problem. Okay, that's done. Now, all of you check question number 2. Okay, Nihat, do you have this question paper in front of you? Nihat, could you hear me? Hello? Nihat,
Yes.
are you? Yes. Yeah. Do you have that paper in front of you?
Yes, miss.
Oh,
No, it's in my screen.
okay, on the screen. But then you can just check and we can get the answer from you for part A. All of you look at it. They say here some builders decide to measure their personal power ratings using apparatus they already have on site. Okay. The figure shows the arrangement they use. Okay, what is that? There is a pulley and there's a rope and there's another pulley. What they're doing? Okay. They are going to pull that pulley and they're going to lift a load above. Okay, fine. In the table below, these are the three quantities they must measure in order to calculate the power. Okay. Do you remember the formula for power? Power equals to, what do we write?
Work done divided by time taken. So F into D divided by T.
Yes, so work done divided by that. So F into D. So we need to find out F and D. And what is F actually?
Force.
Yes, force multiplied force, but D is the distance here. D will be the vertical height. Okay, and then, yes, then, okay, first of all, distance, the one I say that is D, the vertical height. So on the first, you can write down, we'll be finding out the height or distance and what could be the possible instrument you can use it to measure the distance or height. That can be measured, isn't it? Oh. Now then load we have to measure. Load, weight, both the cases you can write. So that one can be done by a, who knows the name of that device that is used here to measure?
Force meter, no, wait. Yeah.
Yeah, force meter, Newton meter.
Balance.
Spring balance. If you want to write balance, you have to mention spring balance. Okay, that can be used. Then finally, we know that as we say, power equals to work done divided by time. So third quantity we need is time. So what could be the measuring device?
Stopwatch.
Stopwatch.
Yes, use that one. That's the stopwatch. Fine. Stopwatch, clock, both can help us. Okay, fine. Now the next question I want you to check, because I remember when we were having a class with you, that was in grade 8, I think. Grade 8 first time I didn't teach you. Grade 9 when we were discussing the general physics, some of you had a doubt in this particular question. All of you look at it. One workman is measured, workman is measured as having a power of 528 watts. Okay, that man is having this power. His weight is 800 meters. Okay, he can develop the same power climbing a ladder whose rungs are 30 centimeters apart. Okay, how many rungs can he climb in 5 seconds? Okay, For that, we need to find out the distance, and then the distance we can divide by 30 and get the number of jump. Number of that is number of that is okay runs. That one we'll do later. But first, we have to find out the distance he is going to climb during this 5 seconds. So we know the formula right now. We wrote P equals to W by T, isn't it? Work done divided by time. So let us rearrange it and find out the equation for D here. Means in place of W, if I write F into D, any problem, guys? P equals to W by T equals to F into D divided by T. Then I'll write an F into D equals to PT plus multiplication. Then D equals to PT divided by F. F is the force. Okay. And that force will be nothing but the force of the particular man, means his weight. So your power, the power of the man is 528 and the time is 5 divided by 800. If you do this calculation, we'll be getting the distance around 3.3 meters. Okay. Now we have to find out how many rungs he can climb. But they say the distance between the two rungs is actually 30 centimeters. This is centimeter, and the distance that we found, that is in meter. So we are going to convert this meter into centimeter, then divide by 30 to get the number of rungs. So it can be number of rungs equals 3.3 multiplied by 100 and divided by 30. Okay, is there anyone who already has this question done in your book? Can you tell me what is the final answer that we got there? Is there anyone?
11. I just did it with you.
Okay, fine, good. Then it is 11. So number of rungs will be 3.3 into 100 divided by 30, and it comes out as 11. That. Okay. Now let's go to the next one. Okay. Today is 28, right, guys? I'm taking that in next. Now, question number C of this particular part, C part of this question. The human body is only about 50% efficient when climbing ladders. Okay. Calculate the actual energy used from the body of the workman when he climbs 20 rungs. Okay, here they have converted, they have changed the number of rungs, it became 20 now. Okay, fine. So let's see what is our basic equation of efficiency. Do you remember? That is output energy by input energy, or I can write output power by input power multiplied by 100. Here I want to write this energy because they say we have to find out the input energy. Isn't it? Calculate the actual energy. So it is the input energy they are asking us to find out. So we'll write down efficiency equals output energy divided by input energy multiplied by 100. Okay, so just rearrange the equation. Input energy will become output energy by efficiency multiplied by 100. Okay, now output energy, what will it be? It will be work done. Work done by the person to climb this 20 rungs. So we will be writing 800 because that was the weight of the man. So 800 multiplied by 20 rungs, and each rung is having a distance of how much? 30 centimeters. So I'll make it 0.3 centimeters, 0.3 meters. So it will become 800 into 20 into 0.3 divided by, what is the efficiency? If you want, you can use the percentage 50%, but then you will not write multiplication 100. But if you write 15 there, then you will be writing multiplication 100. Then just do the calculation and check what's the answer coming out. I said the work done will become 800 because F into D. So 800 is the force, means that is the weight of the man, multiplied by the 20 rung. So 20 rung multiplied by the distance, that is 0.3 meters. So 20 into 0.3 divided by 50%, or you can write 15 and this side into 100. Just like the equation that we had before. And check what's the answer coming up. Is there anyone got the answer? Nureen, I think it is done before for you, right? It was before we did it. So could you check what was the answer that we got that time?
720? 1720 June? 720.
No, dear. Could you just check? I got it 32,000. 800 into 20 into 0.3 divided by 15. Then If you want, you can add 15% of 15 can be set into 100. Let's check this answer. I got it 32,000. Nureen or any other student who's having this one in front of you, could you check what's the answer that you're getting there?
Miss, I also got 32,000.
Yeah, fine. So then it's correct. Okay, Sanjita, just have a look again. It is 800 multiplied by 20 multiplied by 0.3. Because 30 was centimeter, we have to convert to meter. And divided by 15, they say 15%. You can take that 15%, or you can make it 15 multiplied by 100. So we got 32,000 joule. Okay, fine, done. Now, let's go to question number 3. During Walaikum salam. Yes, you are late. Anika today? Okay, we are doing,
Yes, Miss.
yeah, we are doing 31 May to 11. Question number 2.
Okay.
We finished 1 and 2, now we're doing 3. Okay.
31 May June 11, right?
Yes, yes. Let me read
Miss,
out.
could you? No, it's okay. Because I'm late. You cannot wait for me. It's fine. No, actually, I want you to take out the past paper.
Okay, good. During a period of hot weather, the atmospheric pressure on the pond is, remains constant. Okay, the pressure remains constant, is it? Atmospheric pressure on the pond. Okay, fine. Water evaporates from the pond, so the depth H decreases. Okay, it will be there because it is going to evaporate from the top. So definitely the height is going to decrease. A. Study the diagram. Okay, all of you check. Study the diagram and state, giving you reason, what happens during this hot period 2. The force of the air on the surface of the pond. Okay, force of the air on the surface.
Miss, the question number, please.
Question number 3 I'm doing now.
3.
Yes.
Okay. It's
Force,
the air pressure question.
yes. The force, they say what will happen to the force of the air on the surface of the pond. As they say the word surface, then we have to consider the surface area. So as the water is going to evaporate first, don't you think that the surface area is going to decrease? Because if you look at the shape of this one, definitely the surface area that we have at this height will be, at this depth, will be less than when water gets evaporated. So our force will also decrease. We have to say that as the water evaporates, the surface area decreases, so force decreases. Okay. Now check the next one.
Miss, as the water evaporates.
The surface area decreases, so the force decreases. Actually, it happens due to the shape of the this shape of this pond, you can say. Okay, because the pond is having a shape which is,
So the force increases.
Exactly, decreases. Surface area decreases.
Oh.
Force increases. Yes. Now the second one, the pressure at the bottom of the pond. Okay, definitely it will decrease because pressure depends on H rho G. So as the water decreases, as the water evaporates, the height of the depth decreases, pressure decreases. Definitely it will be, the pressure will decrease due to the decrease of the height. As the water
Height decreases, pressure decreases.
Exactly. Pressure decreases. Okay. Now, part B of the question. On a certain day, the pond is 12 meter deep. Calculate the pressure at the bottom of the pond due to the water. Okay, for this
H rho G.
H rho. Okay. Come on, do it and tell me the answer.
Yes, miss.
Rama, then
120,000 Pascal.
yes, I think you are right. You can just convert that one to the standard form as well. Then it will become 1, 2, 3, 4, 5. 1.2.
It's 1 to the power 10 to the power 5 Pascal.
Yes, 1.2 into 10 to the power 5 Pascal. Yeah, correct. Now we'll go to the other side. There's a second part of the question. Atmospheric pressure on the hot day is 1.0 into 10 to the power 5 Pascal. Calculate the total pressure on the bottom of the pond. Okay, so we found the pressure caused by the depth of the water. So we are going to add it. Total pressure will become the pressure of water or the liquid added with the atmospheric pressure. So you have to just add them. So 1.2 into 10 to the power 5 plus 1.0 into 10 to the power 5 equals 2.2 into 10 to the power 5 Pascal. Got it, girls? Huh? Okay, done. Now let's go to the next part of the question. A bubble of gas is released from the mud at the bottom of the pond. Its initial volume is 0.5 centimeter cube. Okay, fine. So when it is at the bottom, so definitely the pressure it is going to experience.
Sorry, Miss. Miss, the P2 was 2.2 into 10 to the power 5, right?
Yes, yes.
Okay.
So the next question, they say the bubble is at the bottom of the pond and they give us the volume of this bubble. So we can understand the pressure experienced by this bubble at the bottom of the pond will be 2.2 into 10 to the power 5 Pascal, because that is the total pressure experienced by the bubble when it is at the bottom. And then they say, ignoring any temperature difference in water, calculate the volume of the bubble as it reaches to the surface. Means they are asking us to find out V2. But when it reaches to the surface, what will be the pressure? Girls, you have to understand the question. When it reaches, what will be the pressure for this particular bubble? It reaches the surface of the water. So what will be the pressure? It will be only the atmospheric pressure. So when it is at the top of the, at the surface of the this pond, then the pressure will be only 1.0 into 10 to the power 5 caused by the air pressure, nothing else. So your formula will be that Boyle's law, P1 V1 equals P2 V2. You are finding out V2. So V2 equals, if you rearrange P1 V1 divided by P2. So your P1 is 2.2 into 10 to the power 5 and V1 that was 0.5 and P2 is 1.0 into 10 to the power 5.
So P1, like for what's P1 again?
P1 is 2.2 into 10 to the power 5 because that time the bubble was at the bottom of the pond. The whole pressure will be on it. Atmospheric pressure plus the
okay, so 2.2 into 10 to the power 5 by 0.5 divided by 1.0 into 10 to the power 5.
No. 2.2 into 10 to the power 5 multiplied by 0.5 because P1 V1 is 0.5 divided by P2. P2 is 1.0 into 10 to the power 5. We are finding out V2. So V2 equals P1 V1 divided by P2. Got it now?
It's 1.1
Yes. 1.1 centimeter cube.
centimeter cube.
Yes. Because the other unit is also given centimeter. That. Okay. Now let's go to the explanation question. In fact, the temperature of the water is greater at the top than at the bottom of the pond. Comment on the bubble volume you have calculated in V3. Okay, they say in fact the temperature of the water is greater at the top than at the bottom of the pond. But they told us to consider that there is no difference of temperature when we did the calculation in V2. Now in V4 they are saying it is actually greater. So how can we explain this one with the volume? As we already calculated that the volume got more than before. So if the temperature rises, then what do you expect the volume of this bubble
Increase.
to become? Exactly.
It will increase.
Increase and more. That is why we can write, as the water is warm on the surface, the volume of the bubble should be larger than at the bottom. Or whatever we have calculated. As the water is warm on the surface.
Miss, what's that word? As the water?
Is warm. Because the temperature is higher. Warm on the surface, the volume of the bubble will be larger than calculated. Means the one that we calculated, it will be larger than that also. Larger than the calculated one, or larger than the calculated. Oh, I think it's clear for you now. Let's go to the next question. Let's see if it is from the general physics. No, it is from the electricity, so we'll not do that. Let's go to 32 May, June 11.
Miss, in this variant, did we do question number 2?
Yeah, 1 and 2 both we finished.
Oh, so I missed it.
Okay, no problem. I'll redo if you want that question. If it's not done for you, you can do that. Okay, now the rest of you, even you, Anita, go to 32 May, June 11. Question number 1 I want you to do. Those who are having that paper, that book with you, if you just go to that page, 32 May, June 11. Question number 1 I want you to do. Okay. Now, if you just look at it, the first question they say, complete the table below to identify the physical quantities as scalars or vectors. And you know, this same type of questions you'll be getting in unit 1 and 2 in your A level also. There also they'll be asking you which one is a vector quantity, which one is the scalar quantity, and why they are a vector quantity. Similar type of questions or pattern of questions you'll get there as well. So as I told you, you'll not find that much of difference. Only you have to learn something more about every topic. Okay. So first quantity they gave us speed. I want you to tell me, those who are not done with the question, even if it is done.
Scalar.
Scalar, yes. Then velocity.
Vector.
Then distance.
Scalar.
Yes. Then force.
Vector.
Of course. Then kinetic energy.
Oh, this is scalar.
It's a scalar. That's correct answer. Okay. Let me ask you another one which is not in this group. Momentum.
It's vector.
It's a vector. That's a very good answer because in momentum, the change of momentum, the direction of momentum, these are very important. That is why it's a vector. Okay. Now, if we just look at part B of the question, they say figure 1.1 shows the path of a football as it is kicked along the ground between 3 players. Means A, B, and C. 3 players are there. The distance.
Miss, force is scalar, right?
Force is a vector.
Oh, okay.
Kinetic energy is vector. Okay. So
Kinetic energy and force both are vector, right?
kinetic energy scalar, force vector.
Oh, okay. Okay.
Now, in question number B, they gave us the arrangement. 3 players were there. They kicked the ball among them and they have given us the distance from A to B, that was 18 meters, from B to C, 21 meters. Okay. Calculate the average speed of the ball between A and B. And I think, let me see, oh, they have given us the time as well. The ball takes 1.2 seconds to travel from A to C. From player
So
A
it's
to B.
distance
Oh,
by
it's only A to B. Yes.
Miss, what is the question number?
Question
I
number
got it.
1.
It's 18 by 1.2.
Yes, yes.
Miss, which variant?
32, May, June 11, question number 1.
It's 15 meter per second.
Yes, but you will be writing the equation because 2 mark is given. So V equals to G by T. That is our equation. Equals, it will become 18, that is the distance, divided by time, it is 1.2. Then you are getting, I think, 15 meter per second. That is the
Miss, is
average.
it 15?
Yes, 15.
Yes, yes, I'm done with that. I'm actually talking about 2. Did we start 2?
I'm doing now. Player B kicks the ball to player C. It travels with the same average speed. Okay, the speed, the one we calculated in the previous part, it will be the same here. Calculate the time taken for the ball to travel from B to C.
15 by 21.
Oh, no. First, rearrange the equation. We know that D equals to D by T. T equals to D by V. So D is your 21 and V we
So it's
calculated.
21 by 15.
Exactly. And check this out.
It's 1.4 second.
1.4 seconds, no problem. You got that? Now, the next one they say, suggest why the speed of the ball might change during its motion from A to B. Now,
Because of friction.
friction with what here?
Hmm?
Of course, there will be a friction. but
With air.
Yes, because it will be
Air
flying-
molecule.
Exactly, it will be flying through the air. So there can be a friction with the air molecules, which results in air resistance. If you want, you can write in single word, due to air resistance caused by the friction of the ball with the air molecules. Okay. Done, girls. Shall I move to 4? That is B4. They
Cause
say,
air resistance.
okay, you can write it like this, that, okay, you say due to air resistance caused by the friction of the air molecules with the ball. Due to air resistance caused
Yes, Ms.
by,
Gauri.
now let's go for the next part. Discuss whether the average velocities from A to B and from B to C are the same. Average velocities, girls, they say. Average speed is same, right? But what about average velocity?
No,
Same?
miss, they're not same because they have different direction.
Exactly. So we'll be writing, no, they are not same because the speed remains same, but the velocity changes due to the direction change. Okay, so you'll be writing the velocity changes, or it is not the same. The velocity changes due to the direction of the movement, but the speed remains the same. Okay. Let's see. Okay, question number 2 and 3, both from our question. It's the general physics. So if it is done, I want you to turn the page, go to question number 2. Okay. They gave us a conveyor belt transporting a packet to a raised platform. The belt is driven by a motor. Okay. If you look at the arrangement, they're keeping the packet and it is going through the conveyor belt and going to a higher position. Okay.
We have potential energy.
Good. State 3 types of energy other than gravitational potential energy into which the electrical
Okay.
energy supplied to the motor is converted.
Kinetic energy,
Correct?
heat
Then-
energy, sound energy.
Yes, definitely. When it is going to have a friction, because it is rolling on the top of that conveyor belt is moving on the top of the pulley over there. Means that pulley is also run by the motor. So it is going to have friction. So some heat energy will be produced. At the same time, a huge amount of sound energy will also. So kinetic energy, thermal energy, sound energy. But we cannot mention about the gravitational potential energy. It is already mentioned in the question. Okay. Now take the next one. The mass of the packet is 36 kg. Calculate the inner increase in the gravitational
MGH.
a package when it is raised to a vertical height of 2.4 meters. Okay, fine. So
The answer is 864 joule mgh, so 864 joules.
yeah, it is correct. We can write GPE or EP equals to mgh. Then mass is 36, G is 10, and height is 2.4. If you multiply all of them, you'll be getting 864 joule. Okay. Now check the other one. The package is raised to the vertical height of 2.4 meter in 4.4 seconds. Okay, fine. Calculate the power needed to raise the package. Okay, power equals to work done by time or energy change by time. So here I can use the energy.
So it's 864 by 4.4.
Fine. Correct. Oh, then it comes up. Just wait 1 second.
Miss, would okay. 864.
Your equation will be P equals to W by T equals to E by T. Both are applied here because
Is it 196.4 watt?
yes, I think so. It's correct. If you want, you can write it 196 watt as well because 0.4 can be omitted. It's less than 0.5, or you can write in 0.4 as well. No problem. Now, let's take an answer to the question. Assume that the power available to raise a package is constant. Okay. The power of the motor they are considering. A package of mass greater than 36 kg is raised to the same height. Suggest and explain the effect of this increase in mass on the operation of the belt. Okay, now you tell me what will happen to the belt. We placed a larger mass on the top of it and it has to go to the same